Okay, so now this case we have a something like this. Okay, so we have a two-dimensional. So ABC. A is positive 5 microcoulomb. B is minus 10 microcoulomb. C is positive 7 microcoulomb. This is 15 millimeters and this is 10 millimeters. And then I say determine the resultant electrostatic force on QB. So what is the resultant electrostatic force on QB? So we have to draw the free body diagram on QB. Okay, so my advice would be to draw a Cartesian plane. If you have something like this at the angle, right, you draw yourself a Cartesian plane. Okay, and then you see, okay, let's say this is B. Okay, so that's B, right? That's B. So do you see that the force, if you look at A and B now, the relationship between A and B, A is positive and B is negative. Unlike charges attract. So A attracts B. So B is going to want to go towards A. Do you see that? B is going to want to go towards A. And A is going to want to go towards B. They love each other so much. You understand? Right? C is positive and B is negative. Unlike charges attract. So B is going to want to go towards C because they love each other. And C is going to want to go towards B because they love each other. So can you see this free body diagram here? So B is going to want to go towards C, so that would be, so that's the force of A on B, right? This is the force of A on B, and that's the force of B on A. This is the force of C on B, the force that C has on B, and this is the force that B has on C. So C causes B to go towards C, and B causes C to go towards B like that. But because we focus only on B's free body diagram, so number one is the free body. Okay, you only put the lines here on B. So downwards FA on B, and to the right we got FC on B. So this is how it looks like. Okay, and do you see how the resultant force look like? If you go like this, that is F resultant. That's your resultant force, and the resultant force is a hypotenuse of this triangle. So they ask us to determine the resultant electrostatic force, right? Fe resultant. So if we can get this force and we can get that force, we can use Pythagoras theorem to calculate the resultant. Okay? So that's very important to understand. Okay? Can I just see something more for this? Can I just draw this other ways? Can I just see something? Yeah, more for that. Don't do it like that. No. Don't do the resultant like that. That was a sabotage from me. Can I just redraw this? More for that. So that's your Cartesian plane, right? That's B. So that's B. So downwards is most FA on B, right? And to the right, it's FC on B. This is your resultant. Math. That is FA resultant. That's your resultant force, right? That's X, that's Y. Okay? That's your resultant force. And remember, this force can also be written, can be drawn here as well. That FA on B is the same force. This and this is exactly the same. The reason why I put it here, because so that I can have a nice triangle, and the resultant force goes at an angle. Okay, very, very important. And that angle you must put in your answer as well. So we have FA on B going downwards, FC on B going towards the right, and this is our resultant that we want to ultimately calculate. Okay, so if we got that and we got that, we can calculate FE resultant, and I'm going to show you how to calculate the angle as well. Okay, so what is FA on B is equal to K QA QB over RAB squared. So that's 9 times 10 to the power of 9. QA is 5 times 10 to the negative 6 coulombs. Remember, micro is times 10 to the negative 6. Kanala, you must learn that. No? Nano is times 10 to the negative 9. Micro is times 10 to the negative 6. You must know that. Kanala. Okay? Don't put in the sign. Kanala, don't put in plus and don't put in the minus sign. B is 10 microcoulomb. So just say 10 times 10 to the negative 6. Right? Over. What is the distance? 10 millimeters. What is milli? What is this milli? This milli is times 10 to the negative 3. So therefore, this is going to be 10 times 10 to the negative 3 meters squared. Right? This is the milli. Okay, that's the millimeters. You must write it out 10 times 10 to the negative 3. So it's basically 10 millimeters is basically equal to 10 times 10 to the negative 3 meters. This represents that milli, which you must write out in full. So that's 10 times 10 to the negative 3, and you square that. This is meters. You don't actually have to put that in. If you want to, you can, but yeah. Anyway, this you put into your calculator, and inshallah you will get an answer of 4,500 newtons. And remember, it's going down, so it's down. Okay, so this is 4,500 newtons down, okay, because that's a downward force. And then FC on B is exactly the same process. That's QB QC over RBC squared. So that's 9 times 10 to the 9. B is 10 times 10 to the negative 6. And C is 7 microcoulomb. So that is 7 times 10 to the negative 6 divided by the distance is 15 millimeters. You see there? 15 millimeters. So the milli is times 10 to the negative 3. So therefore it's 15 times 10 to the negative 3 all squared. Okay? And hopefully, inshallah, you'll get an answer of 2,800 newtons towards the right. I'm going to pause for Maghrib, but alhamdulillah, we calculated this force, which is 4,500 newtons, and we calculated this force, which is 2,800 newtons. Now we can use Pythagoras theorem to get the hypotenuse. Using Pythagoras theorem, then we're going to get the resultant force. Then I'm going to show you how to get that angle to get the final answer. Wa akhiru da'wana alhamdulillah rabbil alameen.